This is the Milky Way galaxy. Within it resides over 100 billion stars. As well as spectacular nebulae that act as the furnaces of life throughout the cosmos. Perhaps one of the most interesting things, however, is that in this one section of the galaxy known as the Orion Arm, in one solar system resides a planet which we know as Earth, and is the only place that we know of to harbour life as we know it. The solar system in which humanity lives is made up of 8 recognised planets, those being Mercury, Venus, Earth, Mars, Jupiter, Saturn, Uranus, and Neptune. We will be taking a look at each one individually, discussing their formation, properties, and other pieces of historical information. At the centre of the solar system is of course the Sun, which will also be discussed. The first thing we will be taking a look at, however, is comets. These cosmic snowballs have a nucleus which is commonly made up of supercold methane, ammonia, carbon dioxide and water, of which all are in ice form. The comets themselves also contain other materials such as rocks and debris from around the solar system which make up the outer portions. Their sizes vary greatly from just a few meters to a few kilometers in width. And as comets approach the Sun, they begin to lose mass due to a process known as sublimation. Eventually, these comets will break apart from being so small and from moving at such high speeds. Probably the most famous and well-known comet is Halley's Comet. It has an orbital period of 76 years and will not be at close approach to the Sun for another 38 years. Astronomers have linked the comet's appearances to observations dating back over 2,000 years. The comet was last seen in 1986 and will return in 2061. At the centre of the solar system is the Sun, which provides light and heat to everything around it. Formed approximately 4.6 billion years ago from a collapsed nebula, it is a G2V class star. This means it is the second hottest star in the G classification and is part of the main sequence of stars. It has a surface temperature of around 5,800 Kelvin. Its formation began when the solar nebula began to collapse in on itself under the force produced by gravity. And as this happened, the material from the collapsing nebula began to spin faster and faster, forming a disc-like shape. Majority of the planetary nebula's material, 99.8%, was pulled towards the centre of this disk, which resulted in the formation of the Sun. The remaining material makes up everything else in the solar system, from the asteroids and comets to the gas giants and rocky planets. The Sun primarily consists of hydrogen and helium, of which the former is fused into helium by nuclear fusion within the Sun's core. Temperatures reach around 15 million Kelvin within the core, and this, combined with the incredibly large pressures, allow the fusion process to occur. Currently, our star is around 4.6 billion years old and has about 5 billion years of life within it. It is expected to expand into a red giant due to the extreme radiation pressure within once the fusing of helium begins. It is expected that it will engulf Mercury and Venus during the expansion, even possibly Earth. Eventually, the red giant will lose its outer layers and the Sun will become a planetary nebula. And eventually, once that has dissipated, a very small and very dense white dwarf. Mercury is a god in Roman mythology, known as the messenger deity as well as the idol of travellers. And the planet was so aptly named after him by the Romans due to the planet's rapid rotation around the Sun. The planet claims the title of the smallest in the solar system, having an average equatorial radius of 2,441 kilometers, making it 0.38 times smaller than Earth's. 1 year on Mercury is equivalent to 88 Earth days. However, the solar day on Mercury lasts 176 days, and the time for one rotation of the planet itself is 59 days, making it almost tidally locked to the Sun. It is estimated that Mercury formed around 4.5 billion years ago from the remnants of the solar nebula discussed in the previous section. It is made up of a central core, which may or may not be molten, a rocky mantle and a solid crust. The core makes up 42% of the planet's volume, whereas Earth's only makes up 17%. Mercury is also very dense despite its small size, being the second most dense rocky planet in the solar system, second only to Earth. Mercury is the second hottest planet in the solar system, with its sun-facing side reaching 700 Kelvin. It is also the most cratered planet in the solar system, since it does not geologically heal itself like other planets. It also lacks an atmosphere to help with the burning up of incoming meteorites. Much like Mercury, Venus gains its name from Roman mythology and is named after the goddess of love and beauty. It is the hottest planet in the solar system, rivaling even Mercury with a surface temperature of 753 Kelvin, hot enough to turn lead into liquid. Venus is also only ever so slightly smaller than that of the Earth, with an equatorial radius of 6,052 kilometers, compared to Earth's 6,378 kilometers. Its density is also similar to that of the Earth and has a surface gravity of 8.8 meters per second squared, which can also be compared to Earth's 9.81 meters per second squared. Strangely, Venus rotates in the opposite direction to most other planets in the solar system, and whilst the exact cause of this rotation is not known, it is theorized it is likely due to a collision with an object of some kind. Unlike Mercury, Venus has a very thick atmosphere, with a density 92 times greater than that of the Earth's. The pressure felt on Venus's surface is like being deep below the ocean on Earth. Its atmosphere is made up around 96.5% carbon dioxide, and it is this carbon dioxide which traps heat within Venus and results in a runaway greenhouse effect. It is also estimated that Venus formed 4.5 billion years ago, much like Mercury, and as will be seen, the other planets within the solar system. This is once again due to the leftover material from the solar nebula. It also has a central core, a rocky mantle and a solid crust. It takes Venus around 243 days to rotate once about its axis, and the planet's orbit around the Sun takes 225 days. Its solar day lasts 117 days. The blue marble in which all of humanity currently resides is the planet Earth. It is the third planet from the Sun, and the only place to harbour life that we know of so far. The name Earth is likely to be over 1,000 years old, and has its origins in Germanic wording. Earth literally meaning the ground. Once again, it is estimated to have formed 4.5 billion years ago from the remaining solar nebula material, and has a central core, rocky mantle and a solid crust. The formation of the Earth, however, could not be talked about without mentioning the first natural satellite we come across in the solar system, the Moon. In the young solar system, when planets were forming from the remnants of the solar nebula, many planetismals and protoplanets collided with one another, forming larger objects. One such object, which collided with the forming Earth, was estimated to be around the size of Mars. The collision between Earth and this object threw so much material up into space that it allowed the Moon to form. The Moon is the largest natural satellite compared to its host body within the solar system, and the second densest natural satellite within the solar system. Of course, Earth is the planet which is home to the human race. All that we know of and all of our history has come from and taken place here. 1957 was the year of the first rocket launch into space by humanity, Sputnik 1. Merely 12 years later, Neil Armstrong and Buzz Aldrin would land on the Moon, marking possibly one of the most defining moments in human history, proving that we have the capability to travel to other worlds. Despite having evolved on this planet and lived here for millions of years as a species, there is still much to discover and explore here. Space agencies across the world regularly use satellites to monitor the planet for various pieces of research and general data gathering. A very prominent and important topic is climate change, and these satellites can be used to look at our atmosphere and determine areas of high greenhouse gas emission, and steps can then be taken in an effort to reduce these emissions. Mars is another planet named after a Roman god, namely Mars, the god of war, due to the planet's reddish colour being reminiscent to that of blood. As you may have already guessed, this planet was indeed formed 4.5 billion years ago from the same material as Mercury, Venus and Earth. Mars is about half the size of Earth and also has a central core, rocky mantle and a solid crust. Mars' red appearance comes from the oxidation of iron minerals within its dirt, and the planet's atmosphere is made up of mostly carbon dioxide, nitrogen and argon gases, and is fairly thin compared to the likes of Earth and Venus. Due to this, Mars does not have as much protection against meteorite impacts. The temperature on the surface tends to vary from 293 Kelvin to 120 Kelvin, depending on whether or not that side is facing the Sun. The thin atmosphere also does not do a very good job at keeping heat within the planet, hence the stark difference in temperature. Mars has two small moons named Phobos and Deimos, and are named after the horses that pull the chariot of the Greek god of war, Ares. A topic of great discussion is the potential of finding life on Mars. It is currently believed that for life to exist, a few criteria must be met. Bear in mind, however, that there is no one definition of life universally agreed upon. But things we consider to be alive do have things in common. Living organisms all need to respond to their environment, grow and adapt, reproduce, take in energy, have a metabolism, maintain homeostasis, and pass on traits to their offspring. Of course, being alive does not mean something walking around with two legs like a human. Bacteria, for example, meet all of the aforementioned criteria, and so can be considered to be alive. Whilst it is unlikely for life to exist on Mars now, scientists are looking into the planet's past to determine whether things like flowing water ever existed. Meteorite samples from the planet can also be examined to see if there are fossilized remains of organisms, such as bacteria. Whilst currently there is no concrete evidence supporting life on Mars, the search continues. In the current history of Martian exploration, only probes, landers, rovers, and a single helicopter have had the chance to survey the planet. In recent years, however, there has been a lot of talk of sending humans to Mars. It is only recently that traction has been regained for sending humans back to the Moon, so whilst Mars may be a way off yet, current organisations such as SpaceX have spoken in the past about the challenges of sending humans to the Red Planet, and finding ways around those challenges. This concludes part 1 of the tour of the solar system. In part 2, we will be looking at the outer solar system, including the asteroid belt, Jupiter, Saturn, Uranus and Neptune. We'll also be taking a look at the Kuiper belt.